Northern California is home to the Allen Telescope Array, a very unusual telescope. It's listening for radio signals which come not from astronomical objects, but from alien civilizations. The receivers on each of these telescopes are so sensitive that the signal from a single mobile phone would overwhelm their delicate electronics. That's why they're here. The ring of mountains around me helps protect them from the hubbub of everyday life, mobile phones, microwaves and all. The telescope array is owned and run by the SETI Institute, a private organisation dedicated to the search for extraterrestrial intelligence. It's been a hard struggle, not least because governments are reluctant to finance a search for little green men. One of the central figures in that struggle is Dr. Jill Tarter.
As you can see, we've got 42 antennas and on our way to 350. And the idea is to build an array of a large number of small dishes because it allows us to look at a very large area of the sky all at once with very good spatial resolution. And we've built a telescope that can do SETI and radio astronomy at the very same time.
Because you can just piggyback on whatever the radio astronomers
We just share this big piece of the sky. And the radio astronomers are making images of galaxies or the hydrogen distribution out to 1 billion light years. And I'm in that same patch of sky finding stars to point the telescope to. We use different back ends, so it's all about silicon. It's all about digital signal processing.
And computing power.
We couldn't do this a decade ago, but now we can. Come on, we've got some Bombay doors here, and I'll open them up and show you. Right. Grab this.
Okay.
Ready?
Yep. Got it.
Now pull. And here we go.
Okay.
So now, if you look inside here, what you're looking at is the secondary reflector. So radio waves have bounced off the big dish up there onto the secondary reflector, and then they're focused back here.
Wow, look at that.
Isn't that amazing? I always think about Saturday morning television I used to watch. The Flash Gordon death rays. That's what that reminds me of.
So what is...
One, to capture very long wavelengths down here.
Okay.
So that's where the 0.5 gigahertz is picked up. It's like a car aerial that works at 0.5 gigahertz.
Mm-hmm.
And up at this end, the short wavelengths, the high frequencies, the 11 gigahertz, are captured by that part of the aerial. So now what we've done, we just put a little circuit board at the end of there, and we use electric traces, copper traces, to turn the signal around.
And then that's ready to head off into your base station.
We take the signal out here, there's another amplifier there. It goes as an analog signal onto fiber optics, which run down the pedestal and underground to the processing system. So that's our entire receiver cabin right here up front in the feed.
And easy to get to if anything needs fiddling with.
That's right, and very simple compared to a standard radio telescope. So keeping it simple was important if you want to keep 350 of these running.
And they look good too.
They look pretty out of this world, I think. I think it's quite appropriate for looking for alien signals.
And we want to do an increment.
The array is used not only by professional astronomers, but by students, learning to analyze the faint radio signals it receives from the universe. It's not just celestial interference the team have to contend with. If a signal from another planet is picked up, they would have to be absolutely sure it's from another civilization, and not from something more at home on Earth.
The real challenge is not to find a signal, but to discriminate against what are our technology, signals from our own technology, and something that might be from somebody else's technology.
By our technology, you mean mobile phones, satellites, aeroplanes?
Microwave ovens, yes, exactly.
We've talked about these as if it's a deliberate signal you're looking for. Are we looking for aliens waving hello, or just side effects, just their leaking signals?
Well, it would be easiest for us to detect a signal that was being deliberately transmitted to get our attention. If you're talking about leakage radiation, if you're talking about a signal that's broadcast for some purpose that another technology has, it probably doesn't have a lot of power in it because it's meant for local consumption. So when we broadcast television or radio signals, we only put enough power in them to reach the next county. we don't put enough power in to reach the next star, right? Because we don't have an audience out there.
So bearing that in mind, where do you look? Which stars are you going to target?
Like the sun, where we know there's a habitable planet, and we start with the closest ones to the Earth, because we could hear the faintest signals, and then we work our way out. So that's one way. That's a targeted search. There's another approach, which is instead do a search of stars, because we think that planets are necessary, and planets are orbit around stars. So let's look where there are the greatest number of stars. And we're planning a search along the plane of the galaxy towards the center of the galaxy, so 20 square degrees of the sky will be surveyed. And in those lines of sight, along the distance to the galaxy, there's somewhere between 4 and 10 billion stars. Now, most of them are very, very far away, which means that if there's a transmitter there, it's going to have to be really knock your socks off strong for us to detect it. But that's an experiment we haven't done. And so if the planet with the transmitter is sitting at the distance of the center of the galaxy, that transmitter would have to be 20,000 times as strong as the Arecibo radar, our strongest signal. But that's not outrageous, perhaps, for an advanced technology intending to try and attract our attention.
What about your gut feeling? Have you got any feeling for whether we're alone in the galaxy or not?
I actually don't have any answer to whether we're alone or not. As a scientist, it wouldn't matter what my gut said or what my belief said. Belief is a verb that belongs with religion. We're talking about evidence and data and scientific exploration. The only thing that you can say...
The completion of the remaining telescopes depends on obtaining further funding. SETI's always been an audacious long shot, but it's hard to think of a grander stage for human ambition than trying to say hello to our neighbours, assuming they're out there.